Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to solve a system of equations by elimination using multiplication. So far we have solved systems using graphing, substitution, and elimination. We eliminated so far using addition and subtraction. Now we can go one step further and show how to use elimination with multiplication. So what happens when the coefficients are not the same, or they're not opposite inverses of each other? We multiply the equations to make them the same by using the least common multiple. So we multiply the equations to make them the same by using the least common multiple, which is also abbreviated as LCM. So let's discuss the steps to solve a system of equations by elimination using multiplication. So step one, we want to determine which variable to eliminate. If the coefficients are not the same, we're going to find the least common multiple. So we're going to determine which variable to eliminate. If the coefficients are not the same, we're going to find the least common multiple. That's our first step. Step two, we're going to multiply the equation and solve for our first variable. So step two, we're going to multiply the equation and solve for the first variable. Then we're going to follow the elimination by addition steps. So your goal is to get an equation into a form where we can eliminate by using addition. And then step three, we're going to plug in the answer that we found in step two to find the other variable. So step three, we're going to plug the answer from step two to find the other variable. Remember, your final answer is always in an XY coordinate. So your final answer is an XY coordinate. And remember, you always want to check your solution. So now let's do an example together. So our directions state, solve the systems of equations by elimination. We have a 10x minus 7y equals 2, and negative 5x plus 3y equals negative 3. So we notice here our coefficients are not the same in both the x and the y. And now we want to determine which to eliminate. So we have 10x and a negative 5x, and then a negative 7y and a positive 3y. If you notice here, if we double 5, we get a 10. Therefore, we have to use a least common multiple to find the additive inverse. So, since all we're doing is doubling our negative 5x, we're going to multiply our second equation by 2. So let's first rewrite our first equation. 10x minus 7y equals 2. And now we're going to distribute our 2 to our negative 5x, which gives us negative 10x, our 2 to our positive 3y, which gives us a positive 6y, and then our 2 to our negative 3, which equals negative 6. So what we did here was we multiplied the whole equation by 2, and it resulted in a additive inverse for our x values. So now we can add them to eliminate. So our 10s are going to eliminate, and now we have negative 7y plus 6y is a negative 1y equals 2 minus 6 is negative 4. Divide both sides by negative 1, the 1's cancel, and you get y equals 4. So we solved for our y. Our next step is to substitute our y value to find our x value. So let's rewrite 10x minus 7y equals 2. We have 10x minus 7. We found out our y value is 4, so we're just plugging in, substituting our y value, equals 2. Rewrite our 10x minus 7 times 4 is 28 equals 2. We have a two-step equation. So we're going to add 28 to each side. 28's cancel. So 10x equals 2 plus 28 is 30. And we want to find out what x equals, so divide both sides by 10. Our 10's cancel. Therefore, your x equals 3. And remember, your final answer is an xy coordinate. So our x value we just solved for is 3. So 3 is our x. And our y value we solved for was 4. So our coordinate is 3, 4. Remember, you can always check your answer. You can plug in your 3 for your x value and your 4 for your y value to see if that works. So see if that works. We have 10 times 3 is our x. We're plugging in our first equation, minus 7, and our 4 is y. And does that equal 2? Okay, this is how we can check it. This is how we can check our answer. And we're using our first equation. So now we have 10 times 3, which gives us 30, minus 7 times 4, which is 28, equals 2. Well, does 30 minus 28 equal 2? Yes, it does. So that answer does work. Let's do another example together. So we have x minus 4y equals 2 and 3x plus 5y equals 40. So whenever you see a basic x, that would be your easiest way to go about using your least common multiple because you're just multiplying it by the number you're looking for. Remember, you need the inverse. So this is a 3x, it's positive. So we want to make it the x a negative. So how do we do that? We would multiply the top equation by negative 3. And now we're going to distribute. Negative 3 times x is negative 3x. Negative 3 times a negative 4y is a positive 12y. 3 times 4 is 12. And then a negative 3 to a positive 2 equals negative 6. Now we want to rewrite our second equation, which is 3x plus 5y equals 40. Notice that we now have a negative 3x and a positive 3x, so they undo each other. We can cancel them out to find the variable. So now we're going to follow the addition method by elimination. The 3x's cancel. So now we're going to add 12y plus 5y gives us 17y equals negative 6 plus 40. Different sign subtract. Keep the sign of the higher number, and that's to give us 34. Next step, divide both sides by 17. 34 divided by 17 is 2. So y equals 2. Now we're going to replace and plug in 2 to find our x value. So let's rewrite our first equation. And you're going to rewrite it in original form. X minus 4y equals 2. You can also rewrite the second equation. That's up to you. You'll get the same answer regardless. So now we have x minus 4. Replace our y value that we just found to 2 equals 2. Next up is to multiply 4 times 2. So x minus 4 times 2 is 8 equals 2. And then our last step, you want to add 8 to both sides. 8's cancel. X equals 10. And our coordinate is in your xy. So our x value we found was 10. And our y value we found is 2. So your answer is 10, 2. Remember, you can always check your work. So checking our work, look at your first equation. X minus 4y equals 2. We found that x equals 10, so replace 10 in for x. Minus 4, and we found out that y equals 2, so replace 2 for y equals 2. And then we have 10 minus 4 times 2 is 8. And is 10 minus 8 equal 2? Yes, it does, so it works. All right, let's do one more problem together. All right, so let's look at number 3. It says 3x plus 5y equals 10, and 5x plus 7y equals 10. And if you notice here, you want to find the least common multiple. So let's look at our x values. We have 3x and 5x, and then our y values are 5y and 7y. The x's are easier in this equation, in this systems of equations, because your least common multiple here is 15. With the y's, it's 35. But notice they're both positive. So you want to make one into a negative and one into a positive. So how do we do that? Well, since 15 is our least common multiple, you want to multiply your top equation by a negative 5. And then you want to multiply your bottom equation by a 3. Okay, you want to find the least common multiple for 3 and 5. But one has to be a negative and one has to be a positive. So after we do that, we have to distribute. We're going to distribute the negative 5 to each term in the first equation. So we're going to say negative 5 times 3x is a negative 15x. Negative 5 to a positive 5y gives us a negative 25y. And then negative 5 to a positive 10 equals negative 50. Now we have to do the same thing to the bottom. You're going to distribute the 3 to each term in the second equation. So you say 3 times 5x is 15x. 3 times 7y is a positive 21y. And 3 times 10 equals 30. So notice here we created inverses with the same coefficient and same variable. And now we're going to follow the addition property using elimination. So the 15s cancel. And now we have negative 25y plus 21y. Different signs subtract. Keep the sign of the higher number. So you have negative 4y equals negative 50 and plus 30 gives us a negative 20. And then our next step, divide by negative 4 on each side. And then y equals negative 20 divided by negative 4 is a positive 5. So y equals positive 5. Your next step is to substitute y for 5 to solve for x. So let's rewrite our first problem, which is 3x plus 5y equals 10. And you can write it in original form. It's easier in original form. So now we're looking for x, so we have 3x plus 5. Our y is equal to 5, and that equals 10. 3x plus 5 times 5 is 25, and that equals 10. We have a two-step equation, so subtracting 25 on both sides. So you have 3x equals 10 minus 15, different signs, subtract, keep us down to the higher number, so it's negative 15. And our last step is to divide both sides by 3. Therefore, x equals negative 15 divided by 3 is a negative 5. So your x is negative 5. And our final answer is an xy coordinate. So our x is equal to negative 5, and our y is equal to 5. So your final answer is negative 5, 5. So now what I'd like you to do is a U-try section. Please complete problems 1 and 2, and we will discuss it in class. Thank you.